that's going. Done with that. Okay, what page is this? 23? Okay, so we're going to go over lesson 3 practice problems first, then we're going over lesson 4 practice problems, and then we're doing more advanced hanger diagrams today. And that'll be on a worksheet, and that's what you'll have for homework. We're going to talk about the modeling, how to solve it using a model, which is a hanger diagram or a tape diagram. And then we're also going to talk about how to solve them using algebra, which is called the algebraic way. It sounds fancy. Okay, number 1 from the lesson 3 practice problems. Yep. Yeah, it does it. It's that strip rattles, this right here. Because there's something like the heaters or the AC on the roof makes it all rattle. Okay, number 1, select all the equations representing the hanger diagram. So when it asks me to select all that apply, usually I look at it and come up with what I think it is first and then just kind of match. So what is on the left side of this hanger diagram? What's on the left side, Leo? 3x. Okay, 3x. How else could I write 3x? Yeah, it's really x plus x plus x, but I can simplify that to 3x. What's on the right side? Did it tell us what each of those boxes meant, or did we just have to assume? Yeah. Okay, we had to assume that each one's 1, so there are 6 of them, right? 1, 2, 3, 4, 5, 6. Okay. So I have x plus x equals 6 in some way, shape, or form. So looking at the first one, does that show that I have 3 x's on one side and 6 1's on the other? Yes. 2, 3, 4, 5, 6. Okay, so A works. What about B? No. Why does B not work, Dawson?
Because
it's multiplication, okay? And hanger diagrams show addition, so B is out. 3x equals 6. What does 3x mean? Leo? 3 times x. Why? I just said that hanger diagrams show addition, so why, Ethan, is this one a possibility?
There's 3 and then each one gets 2. Cool.
Why? Afton?
Because there's 3 x's, so 3 times x would be 5.
So the only time a hanger diagram can show multiplication is if it's repeated addition and we flip it to a multiplication problem. D, x plus 3 equals 6. Brendan?
It's actually like 3 since there's I don't think that's 1.
Nope, that cannot. Because that would just show 1x and then like this would show like 3. So that one is out. X times x times x equals 1 times 1 times 1 times 1 times 1? No, that one's out also. Okay, so A and C are the only ones that work for that problem. Write an equation to represent each hanger. Who can give me their equation? Just lost my dot. For A. Hallie, give me your equation for A. Okay, 2x equals 3 works. Did somebody have something else? So I'm going to write all the possibilities up here. So 2x equals 3 works. Tatum? X plus x equals 3. That works. Anything else? Emmy? Yep, and the only other thing that you could have is 2x equals 1 plus 1 plus 1. All of those are perfectly okay. Which one is the best? Jake?
Probably the 2x equals 3.
Why is that one? Why do you think I would consider that one the best?
It has the most actual numbers instead of variables.
No. Brendan?
Because it just has like less stuff. It's less difficult to understand.
Say that in one word.
It's simplified.
It's simplified, okay? He said less stuff, less complicated. It's the simplest way to write it. Do you guys like complex or do you like simple?
Simple.
You like simple, okay? So the simple way is always the best, but it's not the only. Meyer, what'd you get for B?
W plus 1.3 equals 2.7.
Good job. Is there anything else I could have written for that one? There's really only one other thing. I could have said 1.3 plus W. Just flip-flopped them around. Okay, what about the next one, Leah? What'd you get for C?
3y equals 5.1.
3y equals 5.1. Could I have y plus y equals 5.1? Yes. D, Owen, what'd you get for D?
Z plus 1/3 equals 1/2.
Yep, that's right. 1/2. Z plus 1/3 equals 1/2. Questions on those? Brendan? I don't know. It's just the shape they chose to use. Okay, number 3 on the next page. Write an equation to represent the hanger. Aubrey, what'd you come up with for the equation for 3?
2x equals 14.62.
Okay, good job. 2x equals 14.62. Explain how to reason with the hanger diagram to find the value. That just means if you were explaining someone how to solve it using this, what would you tell them? Tatum? Okay, so you would take 14.62 divided by 2 because you're splitting it into 2 equal parts, okay? These 2 parts have to be equal to 14.62. So you would take 14.62 divided by 2. It doesn't ask for the answer there. If you found it, what is it, 7.31? X equals 7.31. It did ask for it on C, but I told someone they didn't have to tell the classes they didn't have to do C. So if you did it, fine. If not, yeah, it's the same thing. Well, when someone came in and asked about it, because they had it all up on B. Okay, number 4. Andre says that X is 7 because he can move the 2 1s with the X to the other side. Do you agree with Andre? So he's saying he can take these 2 1s to get rid of them. Whoops. To get rid of them from this side, he can just move them over there and pluck them on. What would happen to that hanger diagram? Yeah, it would be unbalanced. It would look more like this. That side would be heavier. So do you agree with Andre? No. And it would make it unbalanced. Does it ask us to solve it on the next part? No? So, but if you explain, what would the value of X be?
3.
So what would we actually have to do?
We would have to take 2 away from
Take away 2, take away 2. How many are left? 3. So you could have had something about that too. So it would make it unbalanced. X would have to equal 3. Okay, number 5, you're practicing tape diagrams. Who can give me the addition sentence for this problem? The addition sentence for A. Brendan?
12 plus 4 equals M.
Okay, 12 plus 4 equals M. Is that one up there anywhere?
No.
Okay, that one specifically isn't up there. What about the next one? Dawson, what's the next one?
It's 12 minus,
Nope, the addition sentence for this.
it's 12 plus,
Nope. Emmy, help him out. 4 plus M equals 12. Okay, C. Brendan?
the question is, M a different value in each one?
I don't know. We can't assume that it's the same.
No, it's not because.
So C,
Yeah, C. What's my addition sentence?
12 plus 12 plus 12 plus 12 equals M.
Okay. And the addition sentence for the last one, Lily.
M plus M plus M plus M equals 12.
Okay, now, what would be an easier way to write 12 4 times? 12 times 4 equals M. Okay, and this one would be 4 times M. We always put the number first, equals 12. Okay, now we just have to play the match game and possibly think about our fact families. Are there any obvious ones that are just straightforward? Or did we have to think about all of them? I see one of them that's pretty straightforward. Which one? B is the same as D, it's just they flip the 12. Okay, so that one's really the only obvious one. Now, so 12 minus M equals 4. That gets us to A or B. Which one could it be? Okay, so let's look. What would the value of M be in this one?
16.
12 plus 4 is 16. So, could this one be 12 minus 16 equals 4? No. That one doesn't. With variables and numbers, our brain's thinking what? 8. Okay, our brain's thinking 8 because we do 12s, 4s, addition signs. Okay, this one, what would that have to be for that to be 12? 8. Could I do 12 minus 12 minus M, which is 8, equals 4? Yes. So 12 minus M equals 4 has to be B. And again, because of fact families, the addition answer on a subtraction goes in front. The addition answer goes in front on the subtraction problem. So which one does that one go with? Which one does A go with? C. And then D has to go with C. A number I don't know divided by 4 equals 12. Or 12 times 4 equals a number I do not know. Okay, number 6. They gave you really hard words, and all they were saying is if that's the length, find the width if the area is 14. So the math problem you would have had to do for A is 14 divided by 2 1/3 equals they're calling it B. What did we get there? 14 divided by 2 1/3. Leo, what'd you get? 6. Even? Okay, 6, and there's no label, so it's units. Do you guys agree with that?
Yeah.
Okay, for number 2, you're taking 14 divided by 4 1/5. What'd you get, Brendan? 3 1/3. Do you guys agree? I don't have the answers in front of me, so I'm going by what you tell me. Okay, 3.3 repeating is okay. Why is 3 1/3 better?
It's already a fraction. Simple to change it.
It's an exact answer. Okay, a repeating decimal isn't an exact answer. It's better than rounding it, but 3 1/3 is the best answer. Next one, you had to take 14 divided by 7/6. Emmy, what did you get for this one? 12 units. Questions on those? Brendan? No? Okay, flip over to the lesson 4 practice problems from yesterday. On this one, you just had 1 through 4. Okay, Kieran's backpack weighs 3 pounds less than Claire's. 3 pounds less than Claire. Is that 3 minus Claire's backpack, or is that Claire minus 3? If it weighs 3 less than Claire's. Claire minus 3. This is one that people mix up a lot because that's given first, so people want to write it first. But it's Claire's minus 3 equals what?
14 is Kieran.
14 is Kieran.
So Claire's minus 3.
No, it should be.
So Kieran's backpack is 3 less than Claire's. So this equals Kieran, right?
Yeah.
Claire's minus 3 equals Kieran's. And it says Claire's backpack weighs 14 pounds. How much does Kieran's backpack weigh? So Claire's weighs 14 minus 3 equals whose? Kieran's. Okay. So now, which of those is correct? Okay, and they changed Kieran to X. So I'm going to make this an X.
I said 14 minus.
Okay, 14 minus 3 equals X works. Are there any other ones?
Yeah,
X plus 3 is also 14. Okay, a lot of you probably got the I, but didn't get the I. That one's kind of confusing. Each notebook contains 60 sheets of paper. Andre has 5 notebooks. How many sheets of paper do Andre's notebooks contain? What do I have to do here, Jake?
You have to take 60 times 5.
So each notebook contains 60 sheets. Andre has 5 notebooks. How many sheets of paper? So 60 times 5 equals his paper, which we're calling Y. Okay, is that an obvious one down there? So that's this one. Are there any others? A fact family that goes with it.
Y over 5 equals 60.
If I had the total and divided it by 5, yep, I should get 60. That one is also a choice. Okay, questions on those two? Number 3, for each equation, draw a tape diagram that represents it. How can I draw 3x equals 18 in a tape diagram? Elise.
Did you skip 2?
I skipped 2? I thought we did 2.
No, that was 1A and 1B.
Oh, there. Okay, I'll go back to 2 in just a second. How do I draw this, Lily? Okay. Good job. Next one, Brendan, how do I draw 3 plus x equals 18?
3, you have to have 2, split it into 2, and then you have to put an X, and then you gotta put a box or a bracket, and then put 18.
Good job.
I don't think it matters, but does it matter if you put one bigger than the other?
Not really. Usually, if it's drawn properly, one is bigger than the other. Last one, 17 minus 6 equals x. Meyer, what do you think I do for that one? Good job. And then my brace and 17. Because remember, tape diagrams show addition. So if I'm given a subtraction problem, I gotta find its fact family. Let me do some math here. So 4, 2, 4, but 1, 2, 3 decimal places. Is that right?
Yep.
The other one, 205 times 4, so 205 times 2 is 410, 820. Are my numbers right? 8 2 zeros. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 0.00820. Questions on those two? That was just a review. Let's go back to number 2 very, very quickly. Oh, you had to solve. Okay. A would have been, you could have had 2.5 or 2.5. Because you had to take 5 divided by 2. For B, you would have had to take 14.7 minus 1.8. What is it? 12.9. Now, this next one is one people typically miss. Looking at this, who can put that into words? What that's asking?
It's asking 1.5 times what?
Not 1.5. Half of what is 6? If I just word it like that, most of you can do it mentally. Half of what number is 6? Tatum? 12. A lot of people give me 3.
Saying that's what I said.
No,
Because half
The answer is
if you add half
of
12
one
times,
half.
you get 6.
half
Three.
of 12, or half of what number is 6? The answer is 12.
But what? Half of 6 would be 3.
Half of 6 is 3, but this does, half of 6 would say 1/2 times 6 equals 3. This says half of a number I don't know is 6. Does that make sense? It's, again, what I've noticed, and again, this isn't just in 6th grade, it's more in 7th and 8th grade, you guys get the harder, the bigger number problems wrong, the ones that you have to physically write out and solve, you get those ones right, rather than the ones like this that you try and do mentally because our brain doesn't always process it correctly. Next one, what math did I have to do? Leo?
You gotta do 3 and then 4 minus a half.
Okay, which is 2 3/4. Ooh, that's an ugly 2. Or 2.75. Next one, we had to take 10 divided by 2.5. What's that one give us? Is it 4 whole? 2, 4, 6, 8. Yep,
25.
okay, yep, that's right. Okay, 4. That one would be 4. Okay, we're going to get into it. If you struggle with number 2, don't stress. That's kind of where we're going to put our focus coming up. What? We're not doing lesson 5 straight from the book. We're going out of the book for a minute.
What we did with the packet.
Kinda. Okay. Next thing we're going to do is do notes. And again, we're kind of mixing model diagrams with algebra. Okay. Afton's going to pass out your notes page. I'm going to get it pulled up on the board. Again, we've already kind of done this. I'm going to connect some dots here. I'm going to take the hanger diagrams and show you how to do it algebraically, which just means within an equation. Thank you. Okay. Look on the side where the first problem is 2x plus 14. Give me just a second to get it pulled up. Plus 14. Okay. So it was actually a slideshow where I printed 4 slides to a page. It says model the following equation. 2x plus 14 equals 15. How can I model that on a hanger diagram? How can I model that on a hanger diagram? Tatum, how can I model 2x plus 14 equals 15 on a hanger diagram?
First, you put a certain shape on the left side. You put a circle with 2 circles with X.
Okay. So we're going to do a circle with an X, and then we're going to do another circle with an X.
And then you're going to put like a square
Okay, that's fine.
with 14.
Okay, and then we're doing a square with 14. And let's just stay consistent. Let's do variables in circles and numbers in boxes. Okay, just to stay consistent. Okay, what goes on the other side, Dawson?
It would be 15.
Okay, just a 15 in a box. Okay, if I were to solve this with a hanger diagram, what work would I show? Lily, what work would I show? Or who can answer that question? If I was to show work on the hanger diagram to find the value of x. Brendan?
I would show like what 2 times what.
Hold on. Nope, we're looking at the hanger diagram. How can I use this to find the value of x?
14 plus 2x equals 15, which is 0.5.
Hold on. We're not, you're focusing on the equation. If I gave you that and said find the value of x, how could I show my work? Leo?
Could you just take away 14?
I have to take away the 14, okay? I would have to take away the 14 there. How can I show that I'm taking 14 away from the other side, Owen? Yeah, I have to show I took it away there. You guys are writing this. This is how you're going to have to do your homework. What's left on this side? I only have 1 left, so I'm going to make a note of that.
So then 2x has to equal 1.
So 2 x's have to equal 1. What math can I do to figure out the value of each x, Hallie? Yeah, I have to divide that 1 by 2. Why?
Because you have 2x.
Because I'm splitting it into these 2 pieces, okay? 1 divided by 2 without any math involved. 1/2, okay? So x would equal 1/2 or 0.5, okay? Algebraically, we follow those same steps. That's why we start with hanger diagrams, because you can see it. Algebraically, you start with your equation.
So will we have like the hanger and then this box too?
Yes. Yep. On the hanger diagram, what did we do first? We subtracted 14 from where? Both sides. You show that. I'm going to write minus 14. Draw a line at your equal sign. Why do you think I'm drawing a line at my equal sign? What is that representing?
Like, so you can have one side for 15 and one side.
That's the center of my balance. Because you guys are good at visualizing things. If I do something to this side of the balance, I have to do the same thing on the other. So if I draw a line at my equal sign, that's showing me if I subtracted 14 here, I also have to subtract 14 on the other side. So now in algebra, we just clean it up. We bring everything down that's left. Did I touch my 2x? So I drop it down. What is positive 14 minus 14? Cancels out. That's why we do it, because it gets rid of it. On the other side, what's 15 minus 14? 1. What did I do next? Leo?
You divided 1 by 2.
Okay, I divided by 2. Here is why we actually divide by 2. What does 2x mean? 2 times x. In equations, we use inverse operations, which is opposite operations, to get rid of things. That's 2 times x, so to get that x by itself, what's the opposite of times 2? Divide by 2. And you don't know that yet, but you know it from the visualization over here. So we show that like this. Divide by 2, we just put a bar. We don't use the divide sign. And then I show divide by 2. What's 2 divided by 2? It cancels out to just become 1x equals, what's 1 divided by 2? 1/2. Just 1/2. And I know that's a lot to take in. Okay, but we're going to use our hanger diagrams to kind of walk us through the steps of solving equations. What's your next problem? 22 equals 4x plus 4. Does everybody have this so I can go on? There it is. Okay, let's model it first. Ethan, how can I model 22 on the left side?
You could do 4
Don't make it hard.
4 boxes.
1 box with a 22 in it, because 22 is on the left side. Brendan, help me with the right side.
You draw 4 circles and then put an X in each one of them.
Okay, because I have 4 circles. And what else do I have?
And you have a 4, so you have to put
There we go.
a box with a 4.
Okay. There's my model. Let's do these ones side by side. We'll solve the hanger diagram while we're solving it algebraically because you're following the same steps. So let's copy down our problem. 22 equals 4x plus 4. If I was solving this with the hanger diagram, what would I need to do first? Tatum? If I was solving it just by using the hanger diagram, what would I need to do first? Okay, I would have to get rid of this 4 because I'm trying to get those x's, find the value of the x's. So I would do minus 4. What's 22 minus 4? 18. How do I need to show that on my algebra equation? First, let's draw our center line. Where am I going to draw my balance line? Under the equal sign. What did we do to both sides? Subtracted 4. So I write it under the positive, the constant out there because that's what I got rid of. 22 minus 4, we've already said is 18. We have 4x left. Positive 4 minus 4 is gone. What would I do next in the hanger diagram, Meyer? If I know this 18 has to be split up amongst those 4 x's. Yeah, I would take 18 divided by 4. Let's do that. Let's just give our answer as a mixed number. 4 goes in 18 how many times? 4. 4 and 2/4, is that the best answer? No. What is it? 4. Okay. How can I show that same thing over on my equation, Leo? Yeah, I show that I'm dividing this side by 4 and this side by 4. That should always cancel out. The purpose of solving equations is to get the variable all by itself. Do I only have an x left over there on the right side? Yes. On the other side, I have 18 divided by 4. I already did the math and said it's going to be 4 1/2. I want you to try the next one on your own. 19 equals 4x plus 14. I don't care if you do the hanger model first and then the algebraic way or if you work them at the same time. Yes, yep. Once you have it, look up, check, and see if you agree. If you have questions, just raise your hand. Anyone still working? Okay, let's go to the next one. What makes the next one just a little bit harder? There's a decimal. Okay, you would do the exact same thing. Let me check something real quick. Okay, let's go ahead and do this next one. How would I model it? How do I model it? Aubrey, what's going to be on the left side of my model?
2 circles with X's.
Okay. What else?
And 1 box with 1.2.
1.2, not 1/2. Be careful, Jake. Dom, what's on the other side? 6.6. Okay, and I'm going to solve it algebraically as we solve the model. There's my line. What would I need to do first, Dawson?
You need to take 6.6 minus 1.2.
Okay, I would get rid of that 1.2 on this side, so I'd have to subtract it over here. I'm just going to line them up. So I have 5.4 left. How do I show that algebraically, Meyer?
You put 1.2 underneath 6.6.
Yeah, so I do it on both sides because I have to balance it out. So I have to show it on both sides. So I'm left with 2x there. Those cancel each other out. We still get 5.4. I'm out of space down there. Emmy, now what?
I take 5.4 divided by 2.
Yeah, because I'm dividing it amongst those two x's divided by 2. Is it 2.7? Has anybody done that math? Right, 27 plus 27 is 54. Okay, how do I show that down here? I'm going to pull this up just because 2x equals 5.4. How do I show that I'm dividing both sides by 2? Brendan? There we go. So cancels, x equals 2.7. Okay, is this stuff super, super hard? No, it's new, but the hanger diagrams give you a good idea of how to translate that into algebra. It depends. Like you have an assignment this week. I think it's Friday, where like it's going to be a mixture. Some of them it'll say solve. It doesn't matter how. Some of them it'll give you a hanger diagram and ask for the equation. So you have to be aware of both. Okay. Your homework tonight. Okay. It's problems just like your notes page. It's more slides from this presentation. It's in black and white is the only difference, but it's the same types of problems.
How would you, wait, would parentheses mean you have to do them first? That wouldn't make
We're going to